Hi guys, we're doing activity 30.2 today, and the title is Solving Rational Inequalities. We're going to solve them two different ways. So if you take a look at the first problem, here's a rational inequality. Just like you had rational equations, we're going to solve it graphically on the left, algebraically on the right. When we get to number 2, same thing, algebraically on the left, graphically on the left, algebraically on the right. Number 3, just algebraically, and number 4, just graphically. So, what I want you to do is think of this as an equation. So we're going to graph the equation, and then we'll worry about what we do with the inequality. So, we've just had a ton of practice, several days of graphing these. So what we're going to do is we're going to find, oopsies, where did it go? We're going to find those 5 things: vertical asymptote, horizontal asymptote, and all of those. Okay, so start by factoring the top and factoring the bottom. You should have gotten x plus 1, x minus 1 for the top. On the bottom, x plus 3, x minus 4. Here are the things we need. So I didn't put holes. If there are holes, we'll add them. So again, we've done a ton of this. Don't worry about the inequality. Just worry about the equation if you were going to graph this. So vertical asymptotes, look at your denominator. First of all, nothing cancels, so there won't be any holes. Our vertical asymptotes are going to be x equals negative 3 and x equals 4. So why don't we go ahead and plot those now? You might want to use a dotted line. You definitely do want to draw them. I just can't do a dotted line right now. I guess I could with an arrow if I want to do that. Okay, so there's my vertical asymptotes. Next, I have horizontal asymptote. You can look at the original or the factor form, either one. This is x squared degree 2, x squared degree 2. So what you do if they're the same is you divide the coefficient. This has a coefficient of 1x squared. This has a coefficient of 1x squared. So 1 divided by 1 is 1. Most of the times we get 0 because the degree of the denominator is larger, but in this case they're the same. So we divide the coefficients. Horizontal asymptote, y equals 1. Okay, pause the video, go ahead and find your x and y intercepts. I'm not going to show all of the steps of that since we've just been doing it. So for my x-intercepts, I got negative 1 and 1. And you can draw those as, or write those as points, but I'm not going to require that. So on the x-axis, I have 1 and negative 1 as points. And on the y-axis, my y-intercept is 1/12, which is not very high. It's definitely below the asymptote, about right there. Okay, so from here, we need to find a little bit more information. You could plug in 10 and see if it's above or below, plug in 10 and see if it's above or below. However, most of the time I have you do this middle column last, but right now it's kind of set up. You know that it's not going to somehow go up because there's no other actually, I guess it could there because it's not an intercept. But this is going to do this. And I've mentioned that because this is approaching from the negative infinity side, on the other side, it's going to go up forever. And then this is either going to come down above 10 or below 10. We know it's not going to touch the x-axis, but it could come down and go above, or it could come down and go slightly below. So what we do need to do is we need to plug in 10 and negative 10 and just see where that falls. So go ahead and plug in 10 and see what you get. Here's what I got when I plugged in 10. Again, I just use a calculator. It's fine here. If my asymptote were at 0, you wouldn't need a calculator at all. All you need to know if it's positive or negative. But here we want to know if it's above or below this asymptote at 1. So when I come over to 10, I'm at 99 78. So that is a little bit over 1. So if my asymptote's at exactly 1, I'm a little bit over 1. So I know it's going to probably come down like this. And then here at negative 10, I'm again, 99 over 98 is just over 1, and my asymptote is at 1, so I'm slightly above the line. And I will get this. Okay? So now that I have it graphed, now I have an equation. Now we want to ask ourselves, when is it less than 0? So let me draw 0. Well, let me get, maybe this will be helpful. So look at your graph right here. Notice here I'm up at 5, I'm up 4, I'm up 3, 2, here I'm up 1, here I'm up 0. This is the only part of the graph I want. So this piece and this piece. So this is at, my asymptote was at negative 3. I don't include negative 3, so we'll use a parentheses. So from negative 3 to negative 1. And then you're going to write union, because there's another piece, from positive 1, not forever. Remember, we're talking about our x values, not our y values. From 1 until I get to 2, till I get to 3, till I get to 4, but not including 4. That's my answer. That is when the graph is, let's get rid of this now. That is when the graph is lower than 0. If you want to take a piece of paper and kind of cut it off at 0, you're trying to find when your graph is less than 0. Remember, you're doing the x values, so from here to here, and from here to here. So this is what you would write for your answer. Let's work on it algebraically now. For algebraically, you're going to just worry about your x values. So you're only going to find your vertical asymptotes and your x-intercepts, which I'm not going to make you redo. But if you hadn't done this left side, you would have to do that. So my vertical asymptotes and my x-intercepts. Once you have those, you're going to make a number line with these values. However many values you have, make a number line and put them in order. So negative 3 is the smallest, negative 1, 1, and 4. To get myself more room, I'm going to go to the next slide, but we're still doing the same problem. So now that I have a number line, the only numbers on your number line, not all of these numbers, your vertical asymptotes and your x-intercepts. Now what we're going to do is we're going to figure out in which case this is positive or negative. So pick a number on this side of negative 3, let's say negative 5. Okay, if I were to plug in negative 5 here, would I get a positive or a negative? Plug in negative 5 there, I'd get a negative. Plug in a negative 5 here, this parentheses is going to be negative. Plug in a negative 5 here, negative. Plug in a negative 5 here, negative. What happens when I have, let me erase that. What happens when I have negative times negative over negative times negative? Well, that's going to end up being a positive over a positive. So over here, I would like you to put positive. Let's do the same thing. Pick a number between negative 3 and negative 1. We'll go with negative 2. Okay, plug in negative 2 here. That's going to give you a negative. Plug in negative 2 here. Negative. Oh, but if I plug in a negative 2 plus 3 is 1. That's positive. Plug it in here. That's going to be negative. What will I get here? A negative times a negative over a positive times a negative. That's going to be negative. Keep going. Plug in a number between negative 1 and 1, maybe 0. Do what we've been doing. 0 plus 1 is positive. 0 minus 1 is negative. 0 plus 3 is positive. 0 minus 4 is negative. Well, notice you have a negative over a negative, which is positive, so this part is going to be positive. Keep going, pick a number between 1 and 4. Let's just go with 2. Pick any number between 1 and 4. Okay, 2 plus 1 is positive. 2 minus 1 is still positive. 2 plus 3 is positive. 2 minus 4 is negative. Well, if I have one negative there and no other negatives to cancel with it, that will be negative. Try a number bigger than 4. Doesn't matter. We'll say 6. 6 plus 1 is positive. 6 minus 1 is still positive. 6 plus 3, positive. 6 minus 4 is still positive. If I have 4 positives, that's going to be positive. Now that you have this number line done, when is it less than 0? Well, positive is not less than 0. Negative is less than 0, so I want this section and this section. Those are less than 0. And what numbers are we between? We're between -3 and -1. Also, we want this section from 1 to 4. If we look back, that should be the same answer we got right here. So algebraically versus graphically, you'll get the same thing. Maybe try the second one before I do it for you. All right, let's work on example 2. We're going to do it graphically and algebraically. Let's do graphically first, and then some of our work will be done for the algebraic part. So first thing you want to do is you want to treat it like an equation, and you want to graph it just like we did in section 29.3 and 29.4 of our last section. So factor the top and factor the bottom, and that should help us find our vertical asymptotes. If I go ahead and look here, x cannot be, x can't be 1, and x can't be 3, so there will be vertical asymptotes at 1 and 3. Let's go ahead and plot that. What did I say? 1 and 3. Okay, there are no holes, so I don't need to fill that out. Nothing canceled, no holes. My horizontal asymptote, let's look at the degree of the numerator and denominator. X squared, that's both degree 2, so you look at the coefficient. 1 over 1 is 1, so my horizontal asymptote is y equals 1. Now I'll go ahead and find the x and y intercepts. Remember, set y equal to 0 for the x-intercept, set x equal to 0 for the other intercept. I'll go ahead and tell you what those are after you find them. Your x-intercepts are -1 and 6. So let's plot that. -1, 6. And then our y-intercept is -2. Okay, and then you can go ahead and plug in 10 just to see what happens out here, because again, it can go above or below this line. We're not sure. We just know that it's approaching 1 really far out. But we already have passed the x-axis, so we're not sure if it's just going to stay above here or go above here. So go ahead and plug in 10. And when you plug in 10, you're going to get 44 over 63. And then plug in -10. Let's see what that means in terms of our graph. So at 10, is this above or below this asymptote? This asymptote's at 1. 44 over 63 is below 1, so it's just going to be below 1 right there. So that tells me that my graph is going to do this. And then over at negative 10, again, my asymptote's at 1. I just want to know if I'm approaching it from above or approaching it from below. 144 over 43 is definitely more than 1. It's quite a bit more than 1. That's going to be about 3 or something. Yep, a little over 3. So this is going to do this. You might be wondering why it's so far away from the asymptote. Well, once we get out to negative 600, then we might be a lot closer to this asymptote, but right now we're just not quite there yet. Now this middle part, again, this is approaching from the negative side, so this is going to approach from the positive. Same here, this is going down, so the other side of the asymptote is going to go up. So you're just going to make a parabola looking thing. And you can go down as far as you want. Just don't touch the x-axis. You can go all the way down. You could actually plug in a point here in the middle just to be more accurate, but I'm not requiring that. Okay, so now that we have our graph, let's answer the question. When is this graph, when are these red lines greater than or equal to 0? So take your piece of paper, your hand. Here's 0. Nope. Here's a height of 0. Those are the only parts of the graph that I want. I want this red part, this entire red part, and this red part. Not the whole graph, just above 0. So what values are we at here? So we're at negative infinity, and then we want all of these x values until we get to this x value, which looks like negative 1. So we're going to say from negative infinity to negative 1. Here we are going to include negative 1 though, because it can be equal to 0. So it can go right up to this point because it can be equal to 0, and that has a height of 0. And then I want this whole section, so this is from an x value of 1 to 3. So union 1 to 3. I can't include those because those are vertical asymptotes. We can never touch the vertical asymptote. And then finally, I want this piece of the graph. So remember, here's a height of negative 5, negative 4, negative 3, negative 2, negative 1. Here's a height of 0. That's what our graph is saying. Our graph can only be greater than 0 or equal to 0. So that is at, looks like, what number is that? It's right here. That's a height of 0. So 6. And then it goes on to infinity. So this is my answer. Oh, and I can include 6 because it can be equal to 0 there. It has an exact height of 0 and it's not a vertical asymptote. So a little bit trickier maybe with this on when you can include it and when you can't. The answers are you're always going to have a parentheses if you're talking about infinity or negative infinity. And you're always going to have a parentheses if there is a vertical asymptote there. Otherwise, if I just want to stop the graph at a height of 0, this is basically what I'm doing. I'm keeping that part of the graph when it's above 0. So I can have that point there, which is why I included 6. All right, let's go ahead and that's your answer to write on the line. Let's see if we get the same answer algebraically. So for algebraically, remember, you're going to make a number line, and the only numbers that are going to go on this number line are going to be your vertical asymptotes, so 1 and 3. Let me just write them. 1 and 3, and then you're going to do your x-intercepts, negative 1 and 6. So let's put those in numerical order. So we're going to have negative 1, and then 1, 3, 6. These do not have to be lined up perfectly. You don't have to have the right distance between them. We just need the vertical asymptote numbers and the x-intercept numbers on our number line here. Okay, so let's pick a point between these values. So let's pick a point over here. Let's say negative 2. And let's see what happens when I plug in negative 2. You want to plug it into the factored form, it's a lot easier than plugging it in here because you can do it without a calculator. So if I were to plug in -2 and 1 is a negative, -2 and -6 is -8. Plug in a negative here, you get a negative. Plug in a negative here, you get a negative. 4 negatives is going to end up being positive. Plug in a number between here. We'll go with 0. Plug in 0 as your x. That's going to be positive. Plug in 0. That's going to be 0 minus 6, which is negative. 0 minus 1 is negative. 0 minus 3 is negative. All right, I have 3 negatives. That's going to end up being negative. Okay, pause the video and go ahead and keep going with this. Pick a number between each section. What you will end up getting once you've done that and shown your work, you will have this. You might be wondering, is it always just going to flip back and forth, plus, minus, plus, minus? No. Many times it will, but not every single time. So you do need to check it. Okay, now that we have our number line, let's answer the question. When is our number line greater than or equal to 0? Well, positive is greater than, positive is greater than, and positive is greater than. So those are the sections I want, from negative infinity to -1. I'm going to put all parentheses for now, and then we'll fix it. From 1 to 3. Again, this is interval notation. And finally, 6 to infinity. Okay, so which ones get a bracket? Infinity never gets a bracket, so that one's good, and that one's good. Vertical asymptotes never get a bracket. So 1 and 3, those are fine. We need to leave those because those are vertical asymptotes. Those are not going to get a value there, not an exact value. So it's the other ones that you can turn into a bracket. And again, that should be the same answer we got with the first part. All right, number 3, solve algebraically. So here we don't have a graph to look back at. We don't have all of our work done. But what we're going to do is we're going to do the same thing we just got done doing. So we have a number line. The only numbers on our number line are going to be our vertical asymptotes and our x-intercepts. So those are what we need to find. Now you'll notice they didn't make this very nice and easy for us. We have to get a common denominator so that we have one fraction. So what does this fraction need to get multiplied by? This whole fraction needs to get multiplied by x plus 2. And this fraction needs to get multiplied by x. This is going back to lessons from a while ago. So now we're going to have a numerator of x plus 2. My denominator is x plus 2 times x. And my other fraction, when I simplify the numerator, it looks like it's going to be 2x. And less than 0. Okay, now that we have the same denominator on both sides, let's go ahead and write this as a single fraction. My denominator is going to be this common denominator, and my numerator is going to be x plus 2 minus 2x. So that's going to be negative x plus 2. So now my problem looks kind of like where we started before. We have one nice fraction here. What are my vertical asymptotes? Notice these don't cancel. This one has a negative x, this one doesn't. So no holes. Vertical asymptote is going to be -2 and 0. If I set this equal to 0, x can't be 0. So x equals -2, x equals 0. Those are my vertical asymptotes. And then my x-intercept, I need to plug in a 0 for y. Now, there's no y here, but this is like your y, your output value. We'll plug in a 0 here and see what you get. You should get 2. Okay, once you have these values, those are the ones that need to go on your number line. So my smallest one is -2, 0, and 2. Okay, just like we've done several times, pick a value between each. I'll do one with you. Let's go ahead and go with -3. Okay, so plug in -3 here. A -3 and a negative is +3, plus 2 is positive. The denominator, a negative here, -3 and 2 is negative, and plugging in -3 here makes a negative. So 2 negatives is going to end up giving me positive. Pause the video, go ahead and fill out the rest. You should get negative, positive, negative. Okay, now we're ready to answer the question. When is it less than 0? So which of these pieces are smaller than 0? Negatives are smaller than 0. So these are the pieces I want, from -2 to 0. And then from 3 to infinity. You don't have to worry about any brackets here because it didn't say equal to. Okay, we have one left. This one is only graphically, so it's going to be the quickest one yet. Use the graph of f of x to the right. We want to know when is the graph, the function, greater than or equal to 0. So here is a height of -6. Here's a height of -4. I want to cut off my graph at a height of 0. This is the only part of the graph I want when it's bigger than 0. So I want this part of the graph and this part. Anything else I don't want. So what values do I have? I have from -infinity to 1. And I have, it looks like this is approaching 3 to infinity. Now it has the equal to sign, so we need to check everything. These are fine, because anytime you have infinity, you're going to have a parentheses. A vertical asymptote you are not going to touch. It looks like we have a vertical asymptote right here at, we are guessing here for this number, since we don't have it specifically listed out for us. So this is 3, so that's going to stay. But this one will be a bracket, and that would be my answer. All right, go ahead and do your homework. Make sure you're showing your work, especially for questions like this where I can see your number line. Make sure you get one fraction. Make sure you show me these 4 things. All right, let me know what questions you have.